Welcome, bent riders around the world. My name is Gary Solomon, and you're watching the Laid Back Bike Report. Well, it is a thrill to have you all with us today. Let me tell you what's on today's show. We are going to speak to a couple of guys who are involved with hub motors and a number of other things as well. First, it's Justin from Grin Technologies. Justin is out in Vancouver, British Columbia, and he's going to talk to us about the history of Grin Technologies and what they are working on today. I think you'll find that interesting. And in conjunction with that, one of the things they're working on is a hub motor, and a very special one indeed, that does some Freegen, and they call it the Magic Drive. It was developed out in Israel, and we're going to have one of the founders of Charge with us. Alon is here to talk about that motor, and they are working in collaboration with Grin Technologies. So I hope you guys will enjoy that. First of all, Trey, why don't you bring everybody up here, including those guys, so we can say hi. There is Alon and Justin. Guys, thank you for joining us live today. So, folks, we're going to play the video interviews I did with these guys, and then afterwards, they're going to be right here to answer your questions and comments. So feel free to jump on that live chat, and we will do all of that as we progress. All right. So first of all, the live chat, real briefly then, questions, comments, those are all fine. Put them on there and let us know where you're watching from. We always like to know that as well. Now, we could not possibly do this show without some amazing sponsors. Let me tell you who those are. TerraCycle. Since 1996, TerraCycle has been dedicated to making the highest quality modern recumbent essentials for the modern recumbent rider. All designed, machined, and assembled in Portland, Oregon. Head to t-cycle.com to modernize your ride. And TerraTrike Green Speed. Your vision, whatever it is, TerraTrike has a trike to take you there. And Green Speed cutting-edge designs create performance through Aussie ingenuity. And Laid Back Cycles, your go-to store for Catrike, Ice, TerraTrike, and now AZUB recumbent trikes. They ship nationwide and offer financing to get you rolling. Plus, check out Laid Back Mickey on YouTube for all the latest tips and reviews on recumbent trikes. And Bicycle Man, where you can find new and used recumbent trikes and bikes. We're located in Alfred Station, New York, and have over 100 bents in stock and ready to try. So why wait? Come ride, then decide. And AZUB, known for its rugged construction, thoughtfully engineered details, and responsive customer service. At the very top of the lineup stands the Tie-Fly X, a no-compromise recumbent trike with 3 full-size 26-inch wheels and advanced titanium front suspension. It's the perfect machine for gravel roads and off-road adventures, yet it remains impressively smooth and stable on asphalt. Tie-Fly X is the trike that takes you where you've never been before. And Stein Trikes, where comfort meets performance. Engineered for adventure and built for the journey. Check out stein-trikes-us.com to learn more. And Recumbent PDX. With 150 trikes in inventory, Recumbent PDX is the West Coast only Cat Trike megastore. We have over 20 trikes on our showroom floor just waiting for you to test ride through our beautiful Portland neighborhood. Call or email to schedule your test ride today. And Utah Trikes, your source for custom trikes and quads shipped fully assembled to your home. Visit them in Springville, Utah, or check them out at utahtrikes.com. And Catrike, where passion meets engineering. Lightweight, efficient recumbent trikes proudly made in the USA. Take a test ride today. You can find a dealer near you at cattrike.com. And Baketta Bikes, the leading innovators in two-wheeled recumbent design. Baketta is the only brand of recumbents featuring a full line of electric assist bikes, performance bikes for your favorite club ride, and recreational bikes for spending the perfect day out cycling with friends. Head over to BakettaBikes.com to learn more. And Angletech, your premier destination shop. The experienced crew here can take you step by step and custom tailor a cycling experience that is just right for you. Discover where comfort hits the road at their shop in Colorado Springs or visit their website at cycledifferent.com. And HP Velotechnik. Discover the ride redefined. German engineering meets passion and precision for unmatched comfort and performance. Since 1993, our premium recumbent bikes and trikes have been crafted for pure pleasure, whether it's your daily commute or touring the world. Visit us at hpvelotechnik.com. And Grin Technologies. Grin has championed the electric bike movement for over 20 years, specializing in unique parts for do-it-yourself e-bike upgrades. Their lightweight yet powerful hub motors with regenerative braking are engineered to perfection and can fit on virtually any bike, trike, or quad platform. Check them out at ebikes.ca. All right, guys, let's jump right into it with the recumbent news. Honza sent me this report this morning. It's a good one. Trey, let's have a look.
Hello, everybody. Honza Galla here from Recumbent.news. This time with a report from July 2026 and partly also June 2026, as I didn't have a chance to join the Laidback Bike report last time. So where to start? Let's start with the July 4th, when the United States celebrated its 205th birthday. And Cattrike, the American recumbent trike manufacturer, unveiled a limited edition of their two models, the Dumont and the All-Road, in the blue, red, white color combination to celebrate the anniversary. Then let's have a look at the Bosch motors, because Bosch has been known for its mid-drive motors, but they launched a hub motor, which is a huge surprise, let's say, because by starting producing motors for bicycles, mid-drive motors, they kind of helped diminish the hub motors years ago, and really the world of electric bikes started to be all purely about mid-drive motors. But they have launched a new motor. It's surprisingly not so sophisticated, let's say. It is not a torque sensing, but cadence sensing motors. Of course, you have to combine it either with only a standard cassette or one chain wheel or sprocket for either a single speed solution or some kind of solution like a pinion, gearbox around cranks, and but UT transmission, universal transmission, unveiled also a two-speed kind of simple solution instead of the cassette. So really an interesting news. It is, of course, 250 watts, but only 65 Newton meters. So mostly for urban riding, but possibly also for recumbent trikes or bikes. I have written an article about the motor, quite a long one, so you can find it on recumbent.news. I've also been at the Eurobike show in late June. It has been the world's largest bike show for years, with tens of thousands of visitors. But nowadays, after they moved the location from Friedrichshafen in Germany near the Bodensee to Frankfurt am Main, it started to decline, and there has been a huge drop. Just recently this year, there were very few, like couple of hundreds, of course, but compared to years before, a huge drop in exhibitors and also in visitors. But it was still interesting to go there. There were, talking about recumbents, there was HP Velotechnik exhibiting, although with much smaller booth than before. There was Katanga with Pony Force and the Quad Velo exhibiting. There was a Sixi with their pairs chainless system exhibiting, and also surprisingly the 2.0 company from Norway with their classic velomobile, which is the former pod bike. So they are actively offering it. They still have 15 units assembled, around 180 of them ready to be assembled in the company, in a factory in the Czech Republic. So that kind of brought a more trust into the company. They are also talking about launching an internet shop with spare parts and so on. So although I still have some doubts about their plans for the future production of the new models, I think who did like the pod bike, it might make more sense to buy it now than a couple of months ago. Also, Kinner Velomobile was presented at the Eurobike, which was a kind of surprise. I have asked the owner why they are at the Eurobike and not at the Spezi show, and he said that during the Spezi show they didn't have a Velomobile to show because all were sold or in production. So that was an interesting meeting for me. Then Bambouk was there as well. So I will have a larger report from the Eurobike at the recumbent.news soon, and you will be able to read more about all the recumbent related stuff from the Eurobike there. But let's get back to HP Velotechnik, because they launched several new products or solutions for their Delta TX. They introduced the underseat steering at the Spezi show, and now they have a new type of steering for the overseat steering. So it's not the standard solution, but kind of they call it in German Kardanlenker, so kind of a gimbal type, which requires not so much movement to get the proper steering. And then also they introduced the Bafang motors, the 410, for the tadpole trikes, not only the Delta trikes, and together with it they have a possible combination of the electronic roll-off. So yeah, that was all pretty interesting. And finally, the big news at the HP Velotechnik booth was a Scorpion with a 60 pairs chainless system. So they announced it as a concept trike, kind of a prototype to gain as much attraction as possible from media. They had very good feedback from the visitors, so we will see whether they will launch it or not. I would give it at least 80% they will do so sooner or later. Finally, last weekend there was the World Championship in human-powered vehicles in Sittard, Netherlands, organized by the Belgium and Dutch human-powered vehicles associations or club. 110 participants or racers have participated, 45 volunteers, and overall the atmosphere was very friendly and the feedback is really positive. So it was obviously a successful event, and you can find the results at the a Facebook or internet page of the Human Powered Vehicle Championship, or we will bring an article about it sooner or later. And I think that's all from today's report. I thought that it would be short, but it's probably one of the longest ones. But anyway, enjoy the rest of the Laid Back Bike Report and see you next time. Bye-bye.
All right. Thank you, Honza. That was a great report. Lots of interesting information, especially from Eurobike there. So we appreciate you submitting that to us. And yeah, we'll see you soon. All right. With that, let's jump into the main segment of the show with Justin from Grin Technologies. I had a chance to sit down with him for an extensive interview. And Trey, let's have a look at that right now. I'm very excited to be here with my pal Justin from Grin Technologies out in Vancouver, British Columbia. Justin, thank you so much for joining us today.
So happy to be here, Gary. Can't believe we were both in the same city just a month or two ago without crossing paths at the Spezi show, but glad to make this happen online.
Well, one of the reasons that we actually kind of wanted to get together in the first place for this recording has to do with an event that you guys just hosted. It's an open house at Grin, what they called, I think, the Grin Open House Show and Shine and Beach Potluck there at the headquarters. So first of all, I was hoping you could tell us a little bit about that. Describe it and tell us maybe some of the highlights.
Yeah, that was there's a lot condensed into one quick day there, but it was sort of a follow-up. We had a 20-year anniversary last fall where we had an open house here at Grin, and the people had a great time in attendance. A lot of the visitors enjoyed chatting with each other, and a lot of people suggested it'd be awesome if we did a summer event where people actually brought their bike builds to show them off. And in Grin's founding days, we started an electric bike club back in 2004, over 20 years ago, and we used to pretty regularly host and create events just to spread awareness about e-bikes. This was before anyone had any clue that e-bikes were a thing. You'd spot one maybe every 2 months in the wild. So it's sort of been in our DNA to bring the community together. And since we've seen e-bikes go super duper mainstream in the last little while, which is great in some level, I feel like we've lost a little bit of the special club community feel that we had when it was just a lot more, individual custom builders. So this was a chance for anyone in the Vancouver area, but even people farther afield who've got great e-bikes that they wanted to show off to just come and chat with others, about their builds. It was a chance for people who are kind of new to e-bikes to just test ride what's out there, and a chance for us to showcase some of the things that we're working on in development now, and that could be exciting for new tech that may show up in the years ahead. And then just to socialize, have a picnic on the beach at the sunset, and it was fantastic. What can I say?
All right. Well, no, that's, I think, says almost all of it. So from what I found out about this, I want to just, if we can, get into a couple of details. You built some test ramps, I guess, and you have this product that it's not enough for you to do motors for bikes and trikes and velomobiles. Apparently, you've gotten into wheelbarrows as well. So I think this is of some interest. Tell us a little bit about what that must have looked like.
Sure thing.
And tell us about that one.
Well, one of my great delights working in this industry is just the diversity of just out there applications for which hub motors are useful. E-bikes are such an obvious use case, but we've had people using our hub motors for everything from like downrigger winches for fishermen. We've had people make soccer ball launching things for training goalkeepers. We've had people use them on rail cars for people that are, going along the railways on these pedal powered devices. And of course, there's a lot of interesting things just in moving stuff around. And so wheelbarrows was always something that had been kind of on my mind, like when you're just pushing things up a hill. And I live at a marina where we have a very steep hill to climb at low tide. And you get astutely aware of the effort needed to fight gravity. And so the moment we saw commercial wheelbarrow motors being made available, we sort of jumped on ordering some in, thinking that, well, these people that have been trying to hacking hub motors to work on a wheelbarrow or a similar, cart for moving stuff would just be better served with a purpose-built motor that really goes at a low RPM with a really high torque. But we never really did more than bring the motors in and kind of sell them, piecemeal with e-bike hardware, but then make a dedicated platform that was really suited for what, in this case, a wheelbarrow specifically needs in terms of the mounting installation, how the throttles are attached, and how it bolts on the frame. So we finally, we've sold hundreds and hundreds of these motors, but many cases people doing agricultural robotics. But we really wanted something that just anyone could just throw on their wheelbarrow that they have and make their process of moving stuff around their yard or job site so much easier. And it's, no better way to appreciate that when you're just going up a steep hill. So we built a ramp course up and down our loading bay at Grin. It would have been great for testing cargo bikes or heavy hauling bicycles up and down too, but maybe not safety rated for that. But Grin's interest in this is also just that, as you're also probably quite aware, the overall e-bike market has become very stagnant in North America. It's tons of business companies going out of business. And for Grin, it means that, our general traditional kit sales have been pretty much flatlined for the last little while. And so we're looking to find other markets that are more emerging and growing just to keep our own business more vibrant and exciting. And so this seemed like a great application where no one had quite cracked a great wheelbarrow kit, especially one that can use existing power tool batteries that almost everyone already has in their set of yard or garage equipment.
Okay, so creative. I love that. So, to finish up with the event itself, did you offer some test rides on some of your newer, speaking of new things that you're working on?
Yeah, so I alluded to that.
Tell us a little bit more in detail about what people were riding and what they thought of it.
So the great thing was a lot, we had demos of all the different, we had our very latest skinny version of the all axle motor. So this is the same direct drive motor that's been our mainstay for conversion kits, but made out of a 17 millimeter instead of a 27 millimeter core. So that makes it just 3 kilos instead of 4. And it's very well suited to, 18, 20 inch wheel folding bikes. We're specifically making that tailored for the Bromptons. And then at the other extreme, we had a lot of multi-motor bikes on demo. So especially cargo bikes that have 2 hub motors on them make just such versatile and rugged platforms when you're ferrying 2, 3, even 4 children around. But we also had the first sort of public demonstration of the evolution of this Freegen project that I think I talked to you when we met at the Spezi in 2024. And this was a very novel idea from a company called Charge, based out of Israel, where they realized that they could have the benefit of a geared motor that freewheels, but can also do regenerative braking and can do this without any complicated clutch hardware. And so the kind of innovation I can sort of show you with this little demo motor. So it's the same one I had in Spezi. This is the inside of a typical geared motor. And on Freegen, this sort of very novel technology idea, what they did, you can see the 6 bolts here. these bolts are mounted to the carrier for the planet gears. And so instead of attaching the disc brake to the shell of the motor, the disc brake's been attached to the planet gears. And then what that allows to happen is the motor can freewheel no problem when you're just pedaling. Once you squeeze the brake, you then lock the planet. Now, as the shell is spinning, you can see that the motor's turning internally, and so then the electronics can slow you down with regenerative braking, but you're controlling it with your mechanical brakes. It's incredibly novel and innovative. But the natural evolution for the development of this ended up going down another very interesting path, which is that instead of mounting just the disc rotor on here to add the brake control through the planet drive, the folks at Charge have been experimenting with putting the whole drivetrain on the planet carrier. So while you're pedaling the bike, you're not actually pedaling the wheel directly, you're pedaling the planet gears inside here. So the wheel can be totally still, you can be pedaling and spinning the motor and, effectively have a pedal generator at that point. You can also not be pedaling and have the motor run, and then the shell spins, and then the bike moves forward because the motor's running. And if you're pedaling while the motor's running, then the wheel is spinning at the sum of those two speeds. It basically adds your pedal speed plus the motor speed. And the result of that, very simple change to just how you mount your pedal drive system to the wheel, enables a whole host of features that have been previously just unavailable in the world of bike, and especially in the world of bicycle drivetrains. And just to summarize those quickly, it allows you to do back pedal coaster brake regenerative braking. So you can just push back on the pedals, the system will sense that and just regenerate electronically, and you feel like you're just riding a kid's bike with a coaster brake. It allows you to have an ECVT, so you never need to switch gears while you're riding the bike. The speed of the wheel is just the sum of the motor speed plus your pedal speed, so the electronic controls that govern the motor are dialed in to maintain, so that you maintain just a very uniform pedal cadence. If you push harder, the system senses that, it drives the motor more powerfully, your pedal speed doesn't increase, but the bike speeds up. So you just get this phenomenal acceleration while you're pedaling at 60 RPM in all situations. And it also allows you to control reverse modes by pedaling backwards. And that, specifically on trikes, has been one very tough nut to crack mechanically. If you have any fixed drivetrain that you can reverse by pedaling, it means you don't freewheel when you're coasting forwards. So people have built mechanical clutches to let you pedal backwards and reverse. But by just having the drive on here, you eliminate any additional mechanical hardware. The system and the way it's been implemented on the demo bikes we had, you're pedaling forwards, you have this ECVT, you can go up to very high speeds easily. You just push backwards, you have this coaster brake. The bike quickly comes to a stop doing regen. Once you're stopped, that coaster brake now allows you to actually pedal backwards, and you have a one-to-one mapping of your pedal speed to the reverse wheel rotation. So you can do 3-point, 4-point turns and then head off in the direction you want to go. And it is just like magic. And it's, especially if you think about what it would take to implement that mechanically. So at the show, we had a conventional Delta tricycle that was built up with this. So this was a trike from Electric Cycles that was modified. And the modifications are really minimal to add this capability. And it was such a nice demonstration of the versatility that this adds to specifically trikes with that reverse mode control.
Justin, I'm just going to tear up my interview questions because basically you went through a lot, and we need to, this is so important. As you well know, being at Spezi, the talk was pretty much all about pedal generators. Mm-hmm. The 60 system and a couple other systems were found on so many of the light electric vehicles we found there. Two of the major trike manufacturers have the 60 system, and that seems to be right now the dominant system. But from what you've described for me here, the Magic Drive should be able to provide very similar capabilities to what we saw there. So I would love if you could just take a minute or two and kind of compare what may be the capabilities of the Magic Drive vis-a-vis the pedal drive system from 60.
For sure. And what I wanted, I was thrilled to see how many pedal generators were at Spezi this year. I've been keeping an eye. I've been interested in pedal generators for over 20 years since our first, getting into the thing. It's one of the most obvious things that sort of comes as sort of an inventor, electrical tinkerer. This question, could you not just get rid of the drivetrain, make electricity with your pedals that charges the battery? And the first reaction against it, the gut reaction, it's completely correct, is, that's so inefficient. Anyone who knows a little bit knows generators are only maybe 80% efficient. The motor's 85% efficient. The round net efficacy of that is, 70% at best of your pedal effort will make it to the wheel. But what I came to appreciate, not until quite a bit later, it was after chatting with some other fellows who've been pursuing pedal generators even in the mid-1990s, is that on an e-bike, that doesn't really matter too much because most of the energy is coming from the battery anyways. And so what a pedal generator does is it fully decouples your pedaling effort from what the bicycle is encountering. So you can have as much, whatever cadence you want, whatever torque you want on the pedals, and that's now unrelated to the terrain that you're going and the speed that the bike's moving at. Most importantly, and I think this is part of the reason there's so much interest at a show like at Spezi, is that it frees up the constraints that you have around vehicle frame design when you have this chain that needs to link from the pedals. As soon as you don't have that, and you see this all the time, you look at like a recumbent tandem tadpole tricycle, and it's got a crazily convoluted chain line with tubes and idler pulleys and all this stuff to keep a physical link from wherever the pedals are to wherever the wheel is. So they call drive-by-wire, but really the pedal generator concept liberates you from that. But the downside is that it means you have two motors. You have this motor that is just a generator that you're pedaling and the motor controller to control it. And that's doing nothing at all to help with the assistance moving the bike forward. So you have the weight of a generator motor, the cost and weight of an additional motor controller that isn't moving the bike forwards. And it also means that the motor that moves the bike now has to do 100% of the work. So in a typical e-bike with a chain drive, as you pedal harder, you're relieving the motor's duty. If the motor is stressed or overheating, well, it's you just pedal harder, you can sort of make up the difference and cut the motor a little bit of slack. When you have a pedal generator, you pedaling harder in no way reduces the torque that the motor itself needs to move the vehicle forwards. So it does necessitate having a suitably large-sized motor doing everything. But anyway, so to say, I love pedal generators. I'm glad to see they're entering the mainstream a bit. We really hope that we'll see more sort of aftermarket DIY pedal generator options coming on the market as well. We've worked with a lot of people building their own totally from scratch, but it'd be neat if there were commercial products that simplified that to make it more broadly accessible. But the core thing there is that you have two separate motors. With the Magic Drive, you still have a chain that needs to link your pedals to this. So where all those advantages of getting rid of the drivetrain are not present. Fortunately, almost all bikes being made now have a drivetrain. They're designed to accommodate that. But what the Magic Drive does is give you a number of benefits of a pedal generator system without needing a separate motor and a separate motor controller. So all you have in here is one motor controller, but it still lets you, pedal from a standstill and generate electricity if you want to. It still lets you have an ECVT where you can completely decouple your pedal cadence from the speed of the bicycle and get rid of derailleurs, shifters, and all of that. It also eliminates the need for any torque sensor. That's another benefit of a pedal generator because you're electronically controlling the torque. You don't need to measure it. But on a mechanical drivetrain, if you want to amplify the effort that someone's doing or read what they're doing, you have to add what's often fairly expensive sensors on the bike platform to measure what's going in the legs. On a Magic Drive, it's actually really quite unique because the motor and the pedals are both linked to the same planet carrier. By definition, the motor and the pedal have to exactly produce the same torque at that interface in the same way that, two people pushing each other, if one's pushing harder, it'll just slide over. So to maintain both systems contributing speed to spinning the wheel, they both have to have exactly the same torque. And so the motor torque will always match whatever you're doing with the pedal torque without us having to measure what the pedal torque itself is. So Magic Drive in a nutshell, you don't get the benefit of no drivetrain. That's something unique to pedal generators. But you do get ECVT mode. You have a much lower bill of materials cost because you don't have two separate motors. You can still have neat things like, coaster brake regen, pedal backwards to reverse mode. And you can do that without much reinvention about the motor hardware. The modification to a motor to enable this is relatively minor. You don't have to rebuild a whole hub motor from scratch. We just have to link on the side plate, have a larger ball bearing so that we can pass the planet carrier rotation to the drive cog. And then the last benefit, and the most important one, is that percent efficiency thing. So as I mentioned, on a pedal generator, you're never going to get more than about 70% of the human rider's mechanical output making its way to the wheel. But on a Magic Drive system, when you're pedaling, 100% of the human input spinning that rear hub is going to the wheel itself. As you pedal harder or faster and take up a larger share of the effort, what happens is the motor then is just spinning slower inside it, but there's none of this conversion loss that you have with a pedal generator going to electricity and then back to mechanical. The mechanical link happens with perfect efficiency. And one final point is the backup mode. So in the event of a pedal generator, if ever your drive system does fail or go out of commission, so you lose the electronics failure or something with the motor fails, there's just no way for the bike to move forwards. That's one very legitimate hesitation why a lot of people would really have second thoughts about going with a pedal generator, especially if, say, you're going bike touring or doing long distances. A mechanical system, anyone can kind of understand and troubleshoot it. A pedal generator is in a different league that way. But on a Magic Drive, because there is still a mechanical transmission, it's quite straightforward. So just have a one-way freewheel so that whenever you pedal forwards, you just have a one-to-one gear between your pedals and the wheel to enable you to have a limp to the nearest city mode. That's just not an option with a pedal gen.
Okay, Justin, I would just push back a little from what I understand from the 6E people. Not in the same category as what you describe as having the chain on the hub motor that is clearly going to work in an emergency situation. They do say that if you pedal and you have no battery whatsoever, it will, in an emergency situation, still provide. It will provide energy to the motor, and it will allow it to go very slowly forward, so you're not stranded.
For sure. To clarify, I wasn't talking about a dead battery. I was talking about a broken electronics.
Got it.
So what they're saying is that you can, even without a battery present, they can take the energy of the generator to drive the motor, and then you're just pedaling a very lossy transmission. Like, I don't know if you've ridden like the Navinci hubs. There, you can, if you're tuned cycles, you can kind of feel that your pedal effort is not making its way 100% to the wheel, and pedaling something like a 6E in this mode would be, double or triple the losses of even sort of the worst mechanical drivetrain. So the flat battery or even no battery, there's a workaround. But if there's a blown motor controller MOSFET or a firmware bug or like a cable gets torn, those situations you need functioning.
Perfectly fair. Okay, so now let's finishing up with this. I'm excited to see how this will eventually then compare and compete, because it does seem like you have some advantages. It's going to come down, I think, to some pricing issues and weight issues and all this kind of stuff. But leaving that aside, I know it's too early to talk about that. You've made it pretty clear to me in our previous conversations that this is still pretty much a prototyping, early days kind of thing. Can you give me a projection? Give me an idea about when you think this might appear as a product.
For sure. So I should say, like, all credit to where credit's due. This is really Charge Bike, and especially Alon, the inventor, has been really pushing forward, and they've been partnering with some other large companies to try to find funding and development initiatives and some early market adopters. So at Eurobike next week, there's going to be 3 or 4 demos with the Magic Drive on them, and we're actually going to start taking deposit. So that's something Grin's been really hesitant to do in the past. We've usually been really careful not to pre-sell stuff we don't actually have. There's been a bit of an exploitation of people's willingness to, jump on a new tech and trust a company with some early seed money and then never get a product out of it. But we're confident enough from what we've seen working with Alon specifically that the ability to bring these modified motors into market, and the ability, most importantly, to make these very customized motor controllers. So the motor controller, I didn't go into detail here, but I mentioned that the motor has to track the pedal torque. The torque of the motor always has to match the torque of the pedals. Otherwise, one would just slip. It's two things pushing each other, and if you want to maintain that, they're both sort of pushing equally. But when you're pedaling, your torque is very non-uniform. It's like it's stroke, stroke, stroke. So you get these pulses from 0 to 100 Newton meters up and down. In order to have a smooth feeling when you're pedaling, the electronics needs to make the motor torque also go up to 120 Newton meters, down to 0, back up again in milliseconds of time. Otherwise, you feel like you have this squishy drivetrain that kind of slips on you. And much of the last sort of year and a half of development around this Magic Drive has centered around getting that feeling and behavior to feel right and not just weird and off-putting. And I'm confident enough with what I've seen that we will start taking pre-orders with a hope that we could start fulfilling by the end of this year. And so our hope is to offer both a Freegen system. So Freegen is none of this Magic Drive. It's just a hub motor, a geared motor that freewheels perfectly when you're not using it. And then when you squeeze the brake, you get regen. And then when you use the throttle or pedal assist, it can motor you. So that's one, there's a whole class of, and especially people who are into bike touring, I think it's like a really great motor choice. And then the Magic Drive is for a whole different class of end user. But the other limitation of a Magic Drive is you can't make that small. Just like with the pedal generator system, all of the torque to move the bike has to be coming from the motor. When you're pedaling, you're reducing the speed of the motor, but the torque that the motor has to produce is the same no matter what. It doesn't matter if you're pedaling harder or not as hard. The motor needs to sustain everything. So you need a motor big enough that you could ride throttle only and it wouldn't overheat going up a hill. And so like this demo motor that I'm holding up here, this is a fairly typical geared motor, but in a 26-inch wheel, that would not be able to sustain what a mainstream product would need to have somebody go up a long, steep hill. That would eventually overheat. So the prototypes for Magic Drive, we're dealing with geared motors that are like 5.5 to 6 kilos, which if you're on a direct drive motor, that's a weight people are used to, but a geared motor that heavy it's impressive in what it can do, but it's what's necessary to make this viable in all riding scenarios. But that's it. So by deposits at Eurobike, there'll be units there for anyone who's in Europe who actually wants to test out what it's like to ride one of these things. And we're bullish enough that we think we can start delivering to our early adopters by end of this year.
Very glad to hear that. And that's a change from what you've been telling me before. So thank you for sharing that. Tell us how you got started in this and how you got into Recumbent.
Sure. So I got started in e-bikes just as a university student living at the bottom of a steep hill, just daydreaming for my 8 a.m. class how nice it would be if I could just have a motor help me up. And I was perpetually late because I just lacked the self-motivation to ride in a dark, gloomy, rainy Vancouver, wintry morning and just start my day with a climb. And then at that point, I discovered there was quite a unique and emerging online community of e-bike enthusiasts, people building their own electric bikes. And this was 2003. And so there's a few people at that point who were actually importing the very first Chinese hub motors into North America. And one of those fellows was a unique character by the name of Joshua Goldberg. And he was a Recumbent advocate and fan. So he was also part of many of these Recumbent bike forums. And in the nascent days of e-bikes, it's very fringe and specialized. And if there's one user group for these systems that was open to things that are fringe and different, it was the recumbent bike community. But recumbent bikes are especially plagued by the challenge of being unstable at low speeds. So if you're on a recumbent and you're just trying to start off on an uphill, it's really tricky to crack that initial acceleration to get you to the point of stability. And electric assist just immediately solves that problem. So a huge share of the early e-bike adoption in retrofit kits was amongst the recumbent bike community. And so that's where I got my first exposure. And I shouldn't say my first exposure. Everyone who's into bikes is into recumbent bikes just for at all a geek into aerodynamics and stuff, the legends of how recumbent bikes got banned from bicycle racing because they were so efficient. All of that leaves a strong impression too. But it's been neat to see that they really shepherded in e-bikes into North America. And since then, I've always had, for instance, the demo bike we had here at the show and shine for Freegen was a Bike E, that classic semi-recumbent from the mid to late 90s.
My very first recumbent, as a matter of fact. Sure, the Bike E.
And yeah, I mean, recumbent bikes, it just solved so many problems. In an alternate universe, everyone would ride recumbent bikes, and, you know, upright diamond frame bikes would be these odd things that people ride, you know, when they're going down mountains, but everyone commuting on the road would be in a more comfortable and more aerodynamic posture. But that's just not the way our specific, you know, evolution of this mobility mode has gone. But ever since then, it's been a really core part of Grin's customers. We always attract unusual customers doing unusual things. And, you know, that's included trikes, included recumbents, of course, included the cargo bikes. In the early days of cargo bikes, there was, you know, that predates most electric assist stuff, and cargo bikes were really one of the things that were calling for electric right from the get-go. But recumbents have been a fun challenge for Grin because of the unconventional wheel geometry. And so if there's anything that I'm a sucker for, it's a mechanical design challenge. And so Grin's mission from the get-go has been to try to make electric systems that are as adaptable and compatible with existing bike standards as possible. We really load this idea of an electric ecosystem that's all proprietary. Every company has their own special motor mounts, special electronics, special battery communications. And we've really felt, you know, we loved, as somebody who, you know, has enjoyed tinkering with bikes all my life, I've loved the fact that I could pick up a random bike frame or used bike somewhere and then replace the drivetrain, upgrade to better shifting, upgrade the brakes, replace the fork if I wanted a suspension fork. You know, there's a whole host of things that you can do to keep these platforms running and to keep them using the latest, you know, technology, if you want to call it that. And that doesn't, you know, that's, you know, something fairly unique to bicycles. If you're in the automotive space, there really isn't this world where you can just switch and swap your engine with another car engine, or change out, you know, a different windshield wiper design, or like everything is just very customized for that specific make, model, and year of car. And when you need replacement parts, you're really stuck with this aftermarket supply channel with Lordco that maintains warehouses of millions of unique things. And it's just a nightmare to navigate and not very fun for the at-home person to keep going. So I've long believed that e-bike drive systems should follow the same ethos that exists with the mechanical parts of bikes, and that you could move motors from bike to bike, that you could swap motor controllers and batteries between systems. But yeah, recumbent bikes and trikes in particular have this fun challenge that you've got wheels that are mounted on the sides, and, you know, normal bicycles, you know, everyone's familiar with like a quick release bicycle dropout, and that's been a standard for, you know, decades and decades, where you can just get any front wheel and it'll swap in and out. And everyone agreed that, you know, the spacing between the front forks was 100 millimeters and the diameter of the axle was 9 millimeters. And that way you could have tons of companies making hubs, tons of companies making forks, and the versatility of a, like, you know, a healthy market for those parts to swap in and out. But when it comes to trike manufacturers, they now have this thing where they needed to mount a wheel on one side of an axle, and that didn't have the benefit of a pre-existing standard that, you know, former generations had established. So every trike builder kind of improvised their own design for a hub and for the mount. And so our challenge was to see, and I should say, why would we put motors on the front of the trike instead of the rear? And, you know, I think we had this discussion at our 2024 Spezi show, but a single motor at the rear is by far the most simple, straightforward way to electrify a tadpole trike. But if you have, say, a roll-off hub on the back, you don't have an option of swapping that out for a hub motor. And there's also scenarios where you really benefit from two motors instead of just one. And especially motors in smaller diameter wheels. So often you'll have 20-inch wheels up front, but 26 at the back. And if you can put a hub motor in a 20-inch wheel, you get that much better thrust out of it. So yeah, one of my design goals for making our own motors was a motor that would not only fit all the forks, and then as forks went from slotted dropouts to through axle, where an axle goes in from the hollow end of it. But those through axles came in different diameters. It started at 20 millimeters, then 15, then it went to 12 millimeters for road bikes. And we just said, okay, we can make one universal motor with like a large diameter hollow in it, and then just have little inserts that go in here to fit whatever fork style you have. And on a similar token, we kind of realized that we could make adapters that would allow you to mount the motor single side, you might have a 12 millimeter spindle on some bikes, 20 millimeters on another. That's okay. You can fit a shim to match that ID. But one of the challenges mounting a motor on a bike is that all of the torque of the motor, all the torque that wants to make the motor spin forwards, is also trying to make the axle spin backwards. Sorry, you can't quite see it on that, right? So the axle wants to twist. So the axle needs to be locked really securely to the frame. And we were able to find a universal-ish approach to that where we mount the what I call a single side torque arm on here. So now this is connected to the axle of the motor that has all of this reaction torque. And then we make just a series of adapter plates that's sort of unique to every model of trike that links, you can sort of see it here, it links the holes that are on this arm to the caliper mount for the disc brake. And since almost all these trikes have disc brakes on the front, we just need to figure out what's the position of those mounting caliper holes and at what orientation so that the cable runs neatly. And then we just have sort of one custom piece that we need to make to fit this motor to each model and make of trike. And at this point, I think we have 7 different adapter sets. We just as of a month ago released a new one for the Stein trikes, that company out of Serbia, after having worked with some of their customers and met them at the Spezi show. And our hope is that we can support every single side-mounted vehicle that's out there. If there's enough people that want to run an all-axle motor on it, we'd be able to engineer just 1 or 2 little pieces to make our motor fit on that and open up a range of conversion possibilities that leaves your drivetrain as it is already. Supporting a dual motor drive, and I can go into some of the electrical complexities, but it's physically mounting 2 motors. On a normal bike, it's straightforward. You just put a hub motor on the front, one on the rear. If you've done a side-mounted motor, well, it's just a mirror image or flipped around for the other one on the front. But electronically controlling 2 motors is where the tricky bit gets. And we actually had, a much higher failure RMA warranty rate on dual motor systems than single motor systems, to the point we were even questioning, is it worth us doing this for that, small niche of customers who want to run dual drives, or should we just simplify our lives and stop trying to support wiring up 2 motors, 2 motor controllers to both be powered with a single throttle and a single display, because it introduces a lot of possibilities for, ground loops or misconnected grounds causing current to flow through another signal wire. But at this point, we think we've understood the root cause of at least the majority of those failures. And some of them, everything could work perfectly fine. And then, for instance, if of your 2 motor controllers, if one of them, if the battery ground gets disconnected when you hit a bump, but not on the other system, you can wind up with that entire motor's powering itself through the small wires that bridge or go up to the display or something like that. And then it burns traces. But it was always a mystery. It just suddenly would stop working and there'd be, burnt electronics. But anyways, when we actually looked at it, we've been selling tons and tons of these dual motor splitters, and it actually is a large share of our business are people that actually need the output capability of 2 motors. So to go to your initial question is how does it perform or how does it feel? And so we just released a dual motor video a couple months ago to explain this point. But when you have a motor generating torque, it produces heat. And if you need to make double the torque, so say now you're going up a hill that's just twice as steep. So you have a system that, in your former commute, you had a 6% grade hill, everything was fine. And now you took a new job and now there's a 12% grade hill to climb. So that's twice as steep. And that means that the motor needs to do twice as much torque. But a motor producing twice as much torque generates 4 times as much internal heat. So a system that was, previously maybe getting 80, 90 Celsius, that's totally fine, is now going to clock 200 Celsius. With the same rider, the same pedal effort, just because the grade has doubled. And so if you now add a second motor to a system, you're basically cutting in half the amount of torque that each motor needs to produce, which means you're cutting to 1/4 the amount of heat that they make. And so this is where if you just monitor motor temperature of the same person riding the same, heavily load, whether it's cargo biking or really steep hills, with 2 motors, their motor temperatures rarely crack 50 Celsius, when Singer motors are well up into thermal rollback. So the performance difference is really just night and day. And you could achieve that as well just with one much larger motor. But the problem is that larger motors are now mechanically constrained to fit in the existing space that's allotted for bicycle wheels. And so on a rear wheel, you need space for a 10-speed gears. You need space on the left for a disc rotor and the disc caliper. So that leaves a sort of amount of width available for the motor that you can't really expand on. and just adding a second motor is such an easy way to just open up this whole gamut of higher torque needs, and then really reducing the load on the connectors, the motor controller, the motor. They just are so much happier.
That is really interesting. Now, that brings to mind one of the other subjects we talked about when we were at Spetsy, and that was that special ferrofluid that you used to control some of the thermal issues, which I found fascinating at the time. Where is that now? Are you still using that? Is that still helping out in the single motors? Where is that being used? And have you made progress on using that in other situations?
For sure. I mean, we offer the ferrofluid as an upgrade. We've considered just making it default included in every motor, but it's true that not every system needs it. And even though you only need a small amount, 8 to 10 milliliters, the price of those ferrofluids is extremely high. So it's still adding a non-insignificant cost to the system. But for our customers, about 70% choose to get the ferrofluid. And we've made it, we offer it not just with our Grin motor, but with the other direct drive motors from Crystalite, 9 Continent. We used to sell motors from Muxus and TDCM, all these other brands. And the ferrofluid, it's remarkably compatible with any direct drive motor, as long as the sealing, because it's an organic fluid, it'll tend to wick its way through any crack that exists. So it's important that the motor side plate is well sealed, and that alone, without the ferrofluid, direct drive motors really show their limitations if you're going on a sustained long hill climb, and just by adding that fluid to move the heat from the middle of the motor to the casing of the motor where it can radiate outwards, that sort of gives a 50%-ish improvement in the thermal conductivity, and I should say almost a doubling of the thermal conductivity, and hence a 50% improvement or 40% improvement on how much torque you can do continuously without the motor overheating. But even with ferrofluids, you'll still run into limits. And our motor simulator tools can very accurately predict when you're at a scenario where you're likely pushing what the one motor can handle and dissipate. And when you're at that point, even with the ferrofluid, then a second motor is the simplest remedy if you can't fit a bigger motor in the same platform.
Fascinating stuff. All right, let's go through a few of the products. I was going to go through a number of the products. You've already covered quite a few of them, but there's a couple here. Psychoanalyst. So people are used to the standard displays that come with their bikes, or if they've upgraded with a motor, but the Psychoanalyst is a little bit different, and I think it's got all kinds of features and things that people might find interesting. Tell us a little bit about the Psychoanalyst.
Sure thing. So I could go. I mean, I'm planning to do like a 2-hour everything you ever wanted to know about the Psychoanalyst video, but that came out of a time when I was first making e-bikes in 2003 as an engineering student. The Psychoanalyst in its current incarnation, the version 3 Psychoanalyst, is from 2014. The entire code is written in 8-bit assembly on a PIC16F microprocessor that 15 years ago was like a typical hobbyist micro, is now such an obsolete legacy device. We had plans to develop a version 4 Psychoanalyst that was set in motion in about 2018. I could show you some models here where we went to a more modern micro platform, a much more appropriate sized display with a built-in inclinometer, so the pedal assistance could vary with your hill sensing. And this was at a time when I had found somebody, he went by Techlectic on the Endless Sphere forum, but he was a retired software engineer who was able to take over all of the firmware development that I as a business owner couldn't do. And so things were really starting to move forward to us finally having a modern version of the Psychoanalyst, but that still had all of those neat controls. It still would work universally with any motor controller as long as you wired up the signals right. But sadly, he ended up getting cancer and passing away in a fairly short time window. And then we were right in the midst of COVID when every single firmware engineer was a hot item picked up by every tech company. So a long period lapsed when we just had no ongoing development to carry that forwards. And now I would still love to, take a 2-month semi-retirement and just finish the version 4 Psychoanalyst and get it out there for all those, loyal fans who really believe in
But we both know you're not going to do any semi-retirement anytime
well,
soon.
I should say a retreat or a sabbatical somewhere, but it's hard to develop firmware. And because it's 8-bit assembly firmware on this legacy thing, it's not something that any new, software hires or, recent graduates be that interested in jumping on. So it remains a TBD project, but it's frustrating because the version 4 cycle, it's 95% done. And that last 5% just requires a getting back into that mindset of writing firmware.
Interesting story. So at the risk of having you do another teaser for another one of your 2-hour videos that you want to do, I'm going to ask you about the Main 9 super harness. I don't really understand, but I think it may be related. Tell me what that is.
Yeah. So the super harness was us adding on this little glue-on circuit to do a little bit of what the cycle analyst does. It combines the brake inputs, the throttle inputs, the pedal inputs, and then reduces the number of signals going to the motor controller so we could have proportional regen braking control using these sort of, off-the-shelf generic displays. Now that we have bidirectional throttles as the standard, so the bidirectional throttle, you twist it one way to accelerate, twist it another way to do regen, and the benefit there is it's already combining those two signals into one wire. So with the bidirectional throttle, you don't actually need this extra glue-on circuit. So we've now introduced a simple harness to the mix, which is like a super harness. It plugs into the 9-pin connector, but it's specifically meant just to work with the bidirectional throttles. And this brings, all the, universality of Grin's system, but with a modern display interface.
One of the things I hear a lot from trike riders, recumbent riders who like to travel, especially maybe overseas, and get on a plane, if they have e-assist, it's like you can't because batteries won't fly. And so I saw this LIGO pack product that I see, and I'm not real clear about this. Is this an effort to get around this issue? Tell me, if you could, a little bit about that.
For sure. I was actually just seeing if I have a LIGO on my bench, but I think they're all in the photo booth. The LIGO, it's actually not a new product or a new problem. We started developing the LIGO battery modules in 2014 or so? And so this restriction on flying with lithium batteries was established pretty early on by the IATA, the Organization of International Air Travel, because they understood the risks of lithium batteries being a potential fire source. You can't fly on an airplane with a spare butane or propane tank for your barbecue or for your, lighter fluids or whatever. You can't go on an airplane with fireworks. And it sort of makes sense that large lithium batteries just pose a potential risk of spontaneous fires would be prohibited, especially on passenger airplanes where the risk of a fire is needless to say, quite consequential. And so they very early on, they established an energy limit of 100 watt hours being the largest battery that the airline industry was comfortable with having aboard in the passenger carry-on cargo compartment. And a battery at 100 watt hours, it's small enough that if it does go into thermal runaway, you can easily contain that without the risk of the whole plane going down. And if you actually look at the statistics, there's been, I think it's now upwards of in the hundreds of airplanes that have had lithium battery fire incidents on them. And in all those cases, there was no accident, there's no casualties. In general, the flaming battery or smoking battery was isolated, and then the planes either was able to land as scheduled or divert for a more emergency landing. But quite rightfully, the airline industry has been concerned about this. So when we understood what the restrictions were, we realized, well, hey, we could make a battery that is under 100 watt hours, but then it clicks together to become a larger battery when you're at your destination. And then that opens the possibility of actually traveling with an e-bike, as long as your big battery can break apart into smaller batteries. And so when I was, traveling, I was building electric unicycles back then, and I would bring these electric unicycle prototypes to international unicycling conventions, and I would buy, RC hobby batteries that were lithium polymer, and I'd just make sure they were under 100 watt hours, and I was able to take them with me. So I thought, well, I feel actually quite unsafe traveling with a lithium polymer battery, even though technically that was allowed. Let's make a proper battery with a BMS circuit with quality 18650 cells, and give everyone who wants to the ability to fly. And so the latest version of this, the LIGO 10X, that we released a year and a half ago, and that built on the first generation of battery by being designed in a way that really clicks together quite elegantly with all the mechanical mounts to become one big battery to snap on the bike on a simple rail standard with no extra wires. Previously, we had a bunch of cables you'd have to plug in parallel to connect each battery to the other battery. And that's been working swimmingly well until earlier this year when the airline industry was looking at, these incidents of lithium battery fires, and they realized that the vast majority of situations, it would either e-cigarettes or people's portable power banks. So people have these USB portable chargers for their tablets, for their phones to keep them powered up over the duration of the flight. And the vast majority of all these incidents were just cheap, inexpensive consumer grade power banks suddenly either catching fire or starting to smoke or go into a thermal meltdown event. And so I think it was Southwest Airlines was one of the first to have this very strict maximum one power bank per person limit. And other airlines have sort of followed suit, really limiting people's ability to bring multiple power banks on an airplane. And that, of course, caused great concern for us because the entire business premise, a huge chunk of the business premise of the LIGO battery was giving people the ability to travel with their e-bike. And we've had thousands of customers accumulating probably tens of thousands of flights at this point with almost no incidents flying with LIGO batteries. Most people travel with 4 to 5 packs. That gives you 400 to 500 watt hours. It's kind of a good number for what you'd want at your destination. We've had a few people travel with as many as 12 batteries. I don't recommend doing that. But now there's this policy that you're only allowed 1 or maybe 2 power banks, but they really phrase it as power banks. They don't say spare batteries for other devices. And so because the LIGO battery, it's not a USB power bank, there's no USB short, it's a dedicated battery for a specific device. We ourselves, flew with a bunch of them to the Spezi show. We're going to be flying to Eurobike. We've had no issues to date bringing 4 or 5 LIGOs with us, but we've just last week had our first set of customers who are flying from the UK who were told that there's just a strict maximum 2 batteries per person policy. So this was a couple, they were on a tandem bike, they had 6 LIGOs, and so the airline security took 2 of them because they were only allowed to bring 2 apiece on the airplane. But when we review what's written, there needs to be some clarification.
You mentioned to me in one of the emails about Katanga. Well, I was at Spezi, and not just Katanga. There were a couple other places. It was amazing. Like once in a while, I get to e-assist on some product, and they would casually mention, "Yeah, it's Grin in there." I go, "Oh, well, that's interesting. That's nice to know." So specifically, Stefan told me that they were using Grin. I think in the Velion, it was their light electric vehicle. And then you kind of elaborated a little bit about what that project was about, because it wasn't just one of your standard motors. And I think this also goes to show how many unusual and out of the ordinary products you work on. I think just because you like to do that kind of stuff.
Yeah.
Could you tell us a little bit about that project?
I don't recommend this business strategy to anyone else there. Just in case people are getting ideas.
Probably a bad idea, right?
You should chase every challenge that you see. But yeah, I mean, Katanga's, they've been wonderful to work with. We've been quite interested in this development of what they call intermediary vehicles in Europe, an idea of a class of e-bikes that's like more in the 2,000 watt power realm, that's typically enclosed and is meant to carry 1 or 2 people. And isn't trying to look like a traditional bicycle. And so we've had a lot of these companies using our all-axle motors because of the versatility of mounting them on the side, because the robustness of a direct drive motor inherently. But the downside of mounting the motors on the side like that is that you don't have the built-in torque sensing that you get if you have the motor in the rear wheel of a drivetrain. So while I was working with Katanga, they have this wide velomobile, and for one, and it needs the power of 2 motors because they want to really be able to have a heavy load that can go up in the Alps and not suffer for that. But they also wanted to have the pedal torque sensing. But because this is a quad vehicle, the pedal drivetrain is linking to the rear wheel through, I believe it's a differential in this case, as they often do in these. And that meant that there was actually an opportunity to put our rear motor to use an all-axle motor, but not mount it on the side as we would typically do in a quad, mount it in line with the drivetrain, take advantage of the torque sensing, but also take advantage of the fact that being in the drivetrain lets us change the ratio from the hub motor to the wheel. So, when you mount the hub motor in the wheel, it's now got a gear ratio based just on the wheel diameter. And for this size of vehicle, that means that you really need 2 hub motors to move that weight up that great hill. But if you could effectively have the motor in a 10-inch wheel instead of a 20-inch wheel, well, then you get double the amount of hill climbing thrust for the same motor torque, and one motor would be sufficient, but you'd have to spin it twice the RPM. And so by taking a rear motor in the drivetrain and then playing with the gear ratios, the person pedaling the bike is pedaling the motor. It goes to a derailleur with a torque sensor, so the motor measures the torque that controls the power. And then as the hub motor is spinning, I mean, it's not, if you can imagine this, the motor, the pedaling's on the right side, and then instead of mounting a disc on here, you mount a cog that goes to the axle on the back. And here they can now change this ratio so that the motor spins at double the RPM of the rear axle, and then that gives double the torque on the wheel that the motor here is producing. But double the torque from a gear ratio means half the speed. And this is an S-pedelec bike that needs to go 45 kilometers an hour. But luckily, another of the chasing too many things problems right here at Grin is that we've also been using these hub motors in marine applications where we're spinning a sailboat propeller directly. And so as we were pursuing that, started about 5 years ago, we just got a batch of stators made that had a really fast winding speed. So it's typically the motors spin at like 10 RPM per volt would be a typical motor from Grin. The fastest we have is 12. But for these marine motors, we got some that spin at 20 and even 30 RPM per volt. So for the same voltage, a 48 volt battery, this motor can spin at 1,000 RPM instead of just 500 RPM. On a normal bike, you'd never use that. 1,000 RPM is 100 plus kilometers an hour. Bikes aren't going to go that fast, so there's no point having a motor at that high of a speed. But on this velomobile, because this is geared 2-to-1 to the axle, the 1,000 RPM motor is still spinning the wheels at 400, 500 RPM, whatever is getting 45 kilometers an hour in the 20-inch wheel, and it's able to effectively double the torque output. So now a single motor is having the same output as 2 motors if we went with a hub drive. So now that's cut the cost in half. There's only 1 motor controller instead of 2 motor controllers. The wiring's much simpler. It adds the built-in torque sensing that you couldn't get when you do the 2 motor installs on the side. And overall, it's just like a great solution. And it was, just fun, and what was fun is that this specific project sort of started or became real in my mind when I visited them at the 2024 Spezi show. And at that point, we hadn't dawned on this solution. We were exploring where are we going to mount the torque sensor, how are we going to put the 2 side-mounted motors, but then looking at the drivetrain kind of had that aha moment that actually a single motor could do all the power that's necessary, given that we now have these really high RPM marine windings at our disposal. So I understand we've made, I think, just maybe 4 samples we've sent them so far, but so far it seems to be passing with flying colors all of their performance tests, and I'm really hoping that this can be one of our first sort of OEM integrations of a Grin motor being mounted kind of in an unconventional manner that way.
All right, Justin, let's, before I completely deplete your battery, I have one last question for you. Mm-hmm. What's in the box?
What was in the box is this, which I don't know if you will recognize or some of your customers will, but this is the swing arm of the velomobile from Velomobile World. And so this is, the
bulk.
What's that?
The bulk.
The bulk.
No, yes?
Yes.
Is that the velomobile from Velomobile World?
Exactly.
The bulk. Yeah, exactly. Okay.
Yes. And so they have boxed themselves in a funny corner where they've designed the rear wheel of their velomobile. I guess I've sort of got the pieces here. But they quite unusually have a single side mount rear hub. Sorry, it's all in pieces. But so you could imagine that the rear wheel of this velomobile is just supported from one side. Because they're using disc brakes on the front wheels, they have no need to have a disc rotor on the other side of the rear wheel. So they just have the full cog and drive chain on a single side. But they've, I've been in discussions with Jan, the owner of Velomobile World, for a number of years. They're quite interested in having Grin systems on their velomobiles. But two motors on the sides of a Velomobile is just massively overkill for what most of their customers need. Because a Velomobile is so aerodynamic, they're not in need of that much extra assistance, and two motors ends up being overkill. And as with this project with Katanga, then you don't get the built-in torque sensor. So now they also have to add a torque sensing elsewhere in the system, typically on the bottom bracket. And so it's been an exploration of, is there any way, we've made our front motors so that they could mount in single side applications, but it never crossed our mind that we might want to use our rear hub motors in a single side. And so I had Jan send me this sample of their swing arm so that I could just see mechanically what are we dealing with. And I'm just now experimenting with sort of a first little interface piece of hardware that, this would of course be machined out of hardened steel or stainless steel. And then we could make a very custom version of our rear all axle motor with a 15 millimeter, not a 12 millimeter hollow all the way through. But one of the challenges here is that, as I mentioned earlier, on a motor, there's a huge torque on the axle. And so normally on the Grin motors, the torque arm is out on this side. So when the motor is trying to spin, the axle wants to spin the other way. And there's a torque arm here that's clamped to the frame to stop the inside of the motor from turning. But the single side mount has no hardware to grab a torque arm. And because it's suspended, you can't mount it elsewhere on the frame because, of course, with the relative suspension, that would go all over the place. So we're trying to do, if you look at the end of this, I don't know if it quite shows up, but we've experimenting with
like
this idea.
Star. It's
exactly.
Like a star.
So we've got sort of an octagon star. So my hope that, and I need to, of course, do some mechanical testing on here, is that can interface with a torque arm on this side that has its own star to lock to the motor axle. So the torque of the motor goes to this torque arm, which links it back to the axle, which links it to this mounting plate, which itself has its own starred interface to fit on that. And ultimately, so that all of the motor torque winds up on those three bolts that are on the back of the swing arm, and then safely couples to the frame. So if if all goes well, I may have a mock-up of this that I'll be able to bring to Eurobike to sort of show yet another way that, by designing these motors to be pretty adaptable with a big hollow axle, we can fit these sort of edge case niche applications. And for a small company like Grin, finding niche businesses is the thing that can work for us, because nobody else is going to make a motor for that very specific one-off market case. But I think without too much work, we could adapt ours to fit.
Oh yeah, which makes it all so interesting. I hope marketing people really never get their claws too deeply into you, Justin, because
there's a huge firewall.
Completely flat. Yeah, it would just flatten out the interest in all this. Justin, thank you so much for taking the time, and really, you go so far beyond what anyone else would do as far as explanations. I mean, clearly your enthusiasm and interest in all this is like beyond measure, and it shows. So it's been a pleasure talking to you. I'm very excited to share all this with our viewers, and we'll stay in touch. I can't wait to talk to you next time and see what's new with Grin.
First, Gary, you got to come up to Vancouver. I'll take you out on that sailboat where a marine motor is in full display as well.
Oh, right. With the motor now, that's what it's for, right? For the props, right? That's why it can spin so fast, right?
Yeah. So that's what I'm working on at home. I'm going to be doing a 2-week trip at the beginning of July with the kids. In our 32-foot sailboat now, all powered by one of these hub motors. Anyways, it's been a pleasure. Thanks again for you to spread word about the goings-on in this world of laid-back cyclists. And do hope to see you here in Vancouver. And if not, possibly we'll be at CycleCon in September.
All right. Wonderful stuff there. And I couldn't have worked that interview with Justin without diving a little deeper with the folks that actually came up with that very interesting Magic Drive free gen concept. And so I contacted Alon in Israel with Charge, and he was kind enough to talk to me for a few minutes and talk about the development and the details of the drive. And then when that's over, a short little interview here with Alon. I'm going to have Alon and Justin, who are in the studio live with us right now, to answer your questions, respond to your comments. which we have a few already. So feel free to jump into the live chat with that. And yeah, Trey, let's hear from Alon right now. We are here with Alon with Charge, a company that has put together a very interesting motor that we're going to talk all about. It's not like anything that we have talked about before, so I'm very excited to talk to Alon. Alon, welcome to the Laid Back Bike Report.
Hey, glad to be here.
Very good. All right, well, let's jump right into it. First of all, maybe let the folks know a little bit about you, a little background perhaps, your education, where you are, and that sort of thing.
Well, yeah, I'm here in Israel. Like we say, it's a small, peaceful place. And I'm an electronics engineer by education, but by now I'm basically doing everything. So it's software, mechanical design, and electronics, whatever it takes.
Okay. So the reason that we are talking today is really because of Charge. It's on your shirt there. So there's a company in Israel called Charge or Charge Bike. You can clarify that for us. Yep, there we go. So tell me a little bit about Charge. Where did it come from? What's the idea of Charge, your products, and that sort of thing?
Well, it's me and my partner. My partner, his name is Michael. We go back years. We have been friends and colleagues for different companies, but for many years in the past. And we always talked about, let's do something together. Let's do something special. And at one point, I came to him with an idea. Let's do something fun. We were both at medical companies, which is nice in the electronics department, but it's very, very tedious in regulations, and it's very hard. And we decided to do something fun. So I said to him, let's do a pedal generator, a chainless drive. It was, about 4 years ago, so it wasn't that common. I maybe there was only one type of them on the market, and it seemed like a cool hobby to do, a cool thing to do, to build a bike that has no chain. And then, of course, the obvious problem of pedal generators is that it's very, very inefficient. Now, I wasn't thinking about an e-bike pedal generator. I was thinking about a real bike with battery, but basically a standard bike, but pedal generator. And of course, the efficiency is the killer here. And there's not much to do about it, but at least let's have regenerative braking on the bike. And then I started to learn the subject and why is it so uncommon, or why is it not available on e-bikes. And then it's basically the first time that I saw online how an e-bike hub motor looks like with a one-way clutch. And I said, okay, because of the clutch, you can't do regen. And then, of course, like Justin says in his video, the obvious solution was like, let's add a clutch. But it doesn't make sense, really, because it's really too complex, too expensive, too heavy, not enough torque. It's an e-bike motor needs a lot of torque. So there is no easy way to do it. And at some point, it just came to me. I'm just thinking, wait a minute. The planet carrier is right there near where the disc is. Why not connect the two and then break the planet carrier and just hold the planet carrier inside the motor? And that's it. You just created the engagement of the motor when you want to brake. And that was like a great insight. And it took me a few days later to understand how to control it. As just obviously the obvious way is just add a sensor on the handle to know when you're braking, and then I don't know, by the amount of force you apply on the handle, increase the regenerative braking. But that won't work because there will be a contention between the two. And then it came to me that, wait a minute, just let's look at the speeds of everything. And if you apply the brake, you slow down the carrier more, and then the motor will brake more. And if you release the brake, the other thing happens. The carrier will increase its speed, and the motor can reduce its brake. And that's no sensors and no nothing, and it just works. It's a mirror. It will mirror your torque into the motor. And that's the whole idea of Freegen. And that's when it started. And then it was obvious that this is actually bigger. I'm not sure if it's true today, but when I came up with the idea, it was obvious to us that it's bigger than the pedal generator, because the application of this friction mirror is widespread. It's relevant to any vehicle and it's relevant to a lot of fields. And so we went in the direction of that. And along the road, we figured, why not also pedal the planet carrier? And that is less of an innovation, I must admit, because that's basically what is done in any power split device, like the Toyota Prius, the hybrid transmission is basically that. But I was thinking we can do it with a single motor. It should be okay. It's not as capable as a dual motor solution, but it should do the trick, and it'll be much simpler, and it should work fine. And well, I was thinking after Freegen, after controlling the brake, I thought, well, the pedals will be nothing. I mean, the latencies and the frequency you pedal is so slow that the control cannot be complicated. Well, it wasn't. It was the other way around. Pedaling is super hard to do. It's extremely hard because any fault in the control loop, you immediately feel in your legs. If it's not perfect, it's just not fun. And it turns out that the pedaling experience, the Magic Drive on the pedal side, is way harder to do than Freegen. But any of you who rode it and will ride it in Eurobike and rode it at Spezi and ride it later will see that it's now really fun to ride. It's like riding a bike.
I want to let you continue with that, but it brings to mind that to me, talking about pedal generators as well. So this is a problem that pedal generators really had to solve as well, right? Because nobody wants to ride a bike like this with no feeling of connection. With the pedal generator, you actually have no connection to the motor whatsoever. So that all has to be simulated in software. And yours is probably a different solution, but the overall problem is similar, is it not?
Yeah, in terms of the control, it's basically the same. And if you do, I'm saying my system now can be a pedal generator very easily. I mean, I can add another motor. I can make it a true power split device with a dual motor, with the connection to with the planetary connection, or just do a pedal generator. Actually, the Magic Drive system can be a trainer. You can set it in a mode where if you lock the wheel, then you can just pedal against the motor load without the wheel spinning, and it feels just like a bike. It's like with the inertia, with everything. This is just basically a pedal generator, and yeah, the control is the same. The control software and algorithms are the same, and if it's done right on Magic Drive, it will work fine on a pedal generator application.
Okay, Alon. So at this point, I'm wondering, I don't know if we need to do this afterwards or you're able to do this now. It would be really nice to have some visual look at what you are talking about.
Yeah, so this is the first motor that we're going to release, the first product that we're going to release. It's a hub motor that includes both Freegen and Magic Drive, with both disk and sprocket on the same side, both connected to the planet carrier inside the motor. I'll slice it and you can see. And the OLD here is 135, so it will fit in a normal OLD bike. That's meant to be part of a kit with Grin Technologies. Now, I'll just hide the stuff here, or maybe even section it. Yeah. So, as you can see, basically what happens here is that both the sprocket and the disk are bolted on to the planet carrier inside the motor. And that's basically the trick in terms of hardware. Now, what this means is if you pedal the sprocket or break the disk, basically nothing happens without software, because all you're doing is just applying torque on the planet carrier. It will not move the bike. The planet carrier is free to rotate inside the hub, and doing anything to it will not do anything to you. It will only work if the motor counters your torque. The motor will be connected here. You do not see the motor in here because it's not the product is the transmission. So the motor will be connected here. This is the sun gear, which I'm highlighting. And only if the motor resists or spins up, and you apply torque on the planet carrier, the bike will move or brake. And this is basically the whole thing. It's extremely simple. Mechanically, there really is nothing to it. Everything is in the control algorithms, in making the motor do exactly what needs to be done. And the essence of it is the motor must equal the exact torque that is being applied to the planet carrier. So if you brake, in order for everything to work, the exact same torque you apply on the disc must be matched by the motor. And if you pedal, it's the same. So the motor must track your pedal movement exactly and match the torque at every millisecond. And this is basically it. That's Magic Drive. So I was usually thinking that the main benefit is reducing brake pad wear, especially on an e-bike, especially if it's heavy, brakes wear out fast. And this is a great benefit. Like the pads here will last for a lifetime, for the life of the vehicle. You will never replace pads. But this is not the major benefit. It came to me, it's basically recently that we really did ABS on the Freegen system, like really good ABS on the Freegen system. And the reason we did this like in the last winter, is because I'm usually Freegen is mounted on the rear wheel, and I know that emergency brakes are on the front. So I was thinking ABS is not so important because you need a front brake for emergencies anyway. I was very much wrong. It's like completely wrong. The benefit of ABS on the Freegen is not for emergency brake. It's for every brake, for every normal brake when you're riding on a wet road. And the comforting feel it gives you, the sense of you'll never skid. You brake the rear wheel and you'll never skid. And it's so great. It's like it's a night and day difference from mechanical brakes. And I think this is the best reason why you would want to have Freegen on your bikes. You just brake on a wet road and nothing happens. It breaks you, but nothing else happens. You can curve during the brake, and it perfectly. It matches your track. This is awesome, and it's ABS without modulating the hydraulics, of course. So it's completely smooth. You don't feel anything. It just brakes. The best braking possible. On the market now, there is the Uhuru, the Decathlon power split device, which is the dual motor system. That's the classic way to do that. And it's also an eCVT, but because it has a second motor, it can also assist you. The way it works is the first motor handles your cadence and actually handles your gear, but it's not really your gear, it just changes your cadence. And the second motor is a direct drive motor. It connects directly to the wheel. It's not in the wheel, but it's connected directly to the wheel. And it can add assist. So if the cadence, you can really mimic a gearing system with that setup. On our system with a single motor, you cannot do that. Your torque to the road is constant. It's you. It's your torque that goes to the road. The motor cannot assist you in torque. The motor can add speed. So the motor can maintain your cadence, but it will not add your torque. So like going uphill will feel harder than on flat terrain. It's linear, just like any other bike. The trick is that we're using a very, very low gear. So you're actually always riding in the granny gear. So on the flat, it's super easy. When you're going uphill, it's moderately easy, but you can go at any speed. So you can go in the granny gear at 40 kph, which is like, and this is why Magic Drive is so much fun, because this is an experience you don't have on any other bike. Even with a torque sensor, it doesn't feel the same. Here, it's you really connected to the road in a very low, very high torque gear, but at high speed, which is awesome. You just push on the pedals and accelerate at any speed. It's like, that's the magic.
So this does, in fact, replace the gearing system of a bike, but in a completely different manner than the pedal generator systems do that. So you are still doing away with the derailleur, and you're doing away with shifting and all that stuff. So that's very interesting. So it has its own very different, separate solution to this issue.
Yeah.
I'm trying to see how this fits in with our viewers' main interests, which are recumbent bikes of various kinds, which is very different than the standard bikes you're talking about, because
front wheel, back wheel. Trikes maybe will be a different story, although quads, maybe you can work with that, velomobiles, and there are various recumbent cargo bikes as well. Have you done some thinking about this as well? Where do you envision it fitting in various recumbent categories?
Obviously, if it's more than 2 wheels, then the benefit is enormous because you get reverse.
Right. We didn't talk about that. That's another feature. That's right.
Yeah. We
So
have that
pedaling backwards, right?
Just the pedaling backwards. Yeah. In that case, I would say there are 2 ways to brake on the Magic Drive. One is Freegen, using the disc brake, which is great. That's the most powerful way, and that's the most intuitive way. But the other way is to mimic a coaster brake. You backpedal, and it senses and it's like resisting you. So your legs will not move, but the harder you press, the more you brake. So on a trike, that's perfect. If you go forward and you press back, you slow down until you go to 0, and then the pedals just slowly release, and you can pedal backwards. It's so intuitive. It's like you feel like it's your extension of your body. So for a recumbent with 3 wheels, that's perfect. And I guess having reverse on any velomobile is a good way to go. Another advantage of the trike, I think, on a recumbent, it might be easy to do a mid-drive hub motor, like put the motor someplace not between the rider and the rear wheel. And then you'll have another chain ratio to play with, which can also be very beneficial. You can get much smaller motor with much higher performance that way, because putting the motor in the hub has its limits. So that's one of the ways to go on a recumbent bike. And the other way, which we might offer in the future, are pedal generator, but I don't know yet.
Anything you want to talk about future developments, where you think Charge may be going next? I know you've already got a lot on your plate, but have you been thinking about any future development?
Oh, first of all, production, that's our main thing now. Get what we have out in quantity. But in future development, I really want to do a mid-drive, because then it frees the rear wheel for gearing systems. And also with Justin, we have several interesting ideas, which I can't say right now, but yeah, it's going to be nice. Yeah.
All right. Well, with that, I'm going to say thank you very much for joining us today on Laid Back Bike Report. And we'll be keeping an eye on Charge and see what comes up in the future. I hope we'll have a chance to talk again. Thank you, Alon.
Thank you very much.
And we will have a chance to talk again right now, because there's Justin and Alon. Thank you guys so much for sitting down with me for those in-depth interviews, and for joining us today live on Laid Back Bike Report. Welcome.
Our pleasure. Nice to be here, Gary. Thanks to all the audience who are prioritizing this over our World Cup finals game. I imagine there's a lot of split screens going on as well.
It could be the case that they are not watching us right now and will watch us later on YouTube. But yes, any of you who are not watching or split screening, we sure appreciate that. So, guys, we have some questions. I have a few questions, and we have some questions from our live chat audience. So if you don't mind, let's kind of get into it. First of all, in our news report, of course, Honza talked about his experience at Eurobike, and I know you guys, we talked about it right before you were there. So maybe could you tell us about how that went? What did you find at Eurobike, and how was the reception for your products there?
Go ahead, Justin.
Go ahead, Alon. You go first.
I'll go. So yeah, one of the things that blew me away about this Eurobike was the central theme of alternative pedal drivetrains really taking center stage, with Bosch taking a backseat and Shimano not really being present. It allowed 6E to become sort of the title sponsor of the Eurobike show. So there was tons of pedal generator bikes on all different types of platforms that people were test riding and really getting a firsthand experience of the potential of this technology. But it also blew me and Alon away that there was another bike there with, interestingly enough, a Grin all-axle motor on the front, from a Spanish company that had basically built exactly the same thing as this Magic Drive motor, where they had a geared hub with a link up to the Planet Carrier inside it, a beautifully engineered piece. They'd even made all their own gearing inside. and then implemented a much smaller motor than we had. So then it needs a secondary motor to provide the necessary power to move the bike. And of course, with DJI sort of announcing their upcoming, eCVT system with the dual motors and the mid drive, it's very apparent that there's a potentially a sea range of change in how pedal transmission is accomplished in electric vehicles going into the future. It was wonderful for me to actually get to meet the founder of 60 firsthand. I'm not sure if you've covered the real backstory of why 60 is making this PERS pedal generator, but the man behind that business has this vision where he just wants a highway speed full, three-wheeled electric motorcycle pod, but he just wants to control it by pedaling. He loves this idea of like this human kinetic interface manipulating not just a small vehicle, but a highway roadworthy vehicle. And a key part to that is building and refining this pedal generator tech. It was a wonderful show. And there's a lot of talk about how, what's that?
That was the Vigos, right?
The Vigos, exactly.
Yeah, which was that Spetsy. It's quite a beast, yeah, for sure.
But the one, though, the demo, the concept demo they had at Eurobike seemed much more refined than the Spezi demo, right? So they had a build up that, had. I thought it was really neat to see this on that type of a stage show platform. There's a lot of criticism, that this Eurobike seems smaller than previously. It was true, but I do like that opens up for less mainstream entities to take more of a center stage, and alternative drivetrains was front among them. So it was cool to be part of that. I'll let Alon discuss the feedback.
Alon, go ahead. What was your experience?
Like Justin said, you mentioned DJI, also Goba, another huge Chinese company, came with a rideable eCVT, dual motor mid-drive, MTB eCVT. So right now, eCVT does not need explaining or does not need selling. It's like the mainstream. The two huge Chinese companies, the biggest ones, are pushing it very hard. It's hopefully we still have the hub motor field to play with, because they basically took the mid drives. And for the experience, we had some nice bikes to show. We had a nice trike, like a big cargo trike with two wheels up front, like a tadpole topology. It was cool to show the reverse feature. We also had a Freegen bike, which we didn't have in Spetsy, so a Freegen Magic Drive, so you can brake with the disc, and a coaster brake type bike. All of them were great. All of them, people enjoyed them, and it was great fun to have them the show.
Good. All right. I was going to ask you about that Bosch hub drive, but I don't really think it's very much comment, especially from Honza. It really is not what we're talking about anyways, and it's just Bosch. So I guess that's the major news there. All right. So let's jump into the comments. So this is my pal Ron Thompson, who is the guy who makes the G4 bike. Been on the show a few times, an engineer as well, and he knows what he's talking about. So says, I'm a happy user of the Regen all-axle hub on the G4. Excited to hear the approximately 1 kilogram weight reduction on the new slimmer version. Can you say what the Freegen weighs and the expected efficiency?
The rear motor for the Freegen is 4 kilograms, and the rear motor Magic Drive motor is 4 kilograms. The front will be 3.5. For the front Freegen motor will be 3.5. The efficiency is standard for hub motors. I don't know, 80 plus. I think that's.
I will add we still have, so the rear motor, we've pretty much settled on what motor platform we're going to tool up with these modifications. The front Freegen motor, there's still a few options on the table. And so there are some even lighter geared hub motors that we saw at the Eurobike show that are potentially quite tempting. So it's not yet fully settled which is the baseline platform that we choose to then get modified. But there's I think it was a 2.7 kilogram motor with a high gear reduction ratio and a very high peak efficiency because it was running an amorphous steel stator core, which is also a new and interesting technology to see brought to the world of hub motors. So it's conceivable that the front Freegen motor that we do choose to go to market with will be smaller and lighter, more comparable to the, this Bafang G311 kind of weight class, but with a higher torque and power capability.
Okay. And here's one more from Ron. We're a couple of psychoanalyst comments here for you, Justin. Love being able to accurately track the regen percentage with the psychoanalysts. Okay, that's good. Thank you, Ron.
Yeah, just a comment on that. Oh, sorry,
yeah, sure. Go ahead. No, that's fine. Just put it back up there.
This is for me also one of my favorite stats, and also what a huge number of our customers just love cycling back and just seeing how much regen that they get. It's fun to gamify your own riding to maximize that. And what's cool with the Magic Drive is that it has all those same capabilities. Now, it's not going to work with the cycle. I mean, you could use a cycle analyst on it just fine, but Alon's worked with his own phone app that would connect over Bluetooth to the motor controller. And so we can similarly show and display graphs in real time of the percent regen recapture. And it's been interesting looking at those stats because in theory, the Freegen is a little bit less effective at recapturing that energy in that the disc rotor is slipping slightly. So there is some mechanical energy in braking. Some energy making goes mechanically, but what we see on that percent regen figure is indistinguishable from a perfect regen on any totally lock clutch motor. So you get all those same benefits with the Magic Drive setup too once the controller and the app are present.
All right. So here's a comment from our pal Tig, a fellow Vancouver guy that I'm sure you are aware of. He says we use the Cycle Analyst for all our Electron e-bikes. It's truly the jack of all trades console for the e-bike community. So he is a fan and he knows what he's talking about too. So, and also Tig says we use the Grin Phase Runner in all of our bikes. So nice comment there.
Yeah, I could comment a bit on that. We didn't talk in this video at all about Alon talked about the motor controller and the control code, but that is one aspect or limitation of this system is that you can power the motor with any off-the-shelf motor controller, but to get all these features, you need a way tighter control loop that requires full control over the firmware. And so when we offer these systems, they're going to have to come with their own separate motor controller that won't be backwards compatible with the phase runner or base runner we've been selling or other controllers that are out there. So the controller becomes a little bit more tightly coupled to the motor.
Okay. All right. And here's an interesting comment from Europe, from Liglos. Putting the all-axle motor into a velomobile is problematic in Germany, perhaps all of the EU, because of the 25 kph limit. Would the virtual freewheel be legal here or count as assist over the cutoff speed? That's a good question. I think Alon actually saw that in the comments. Can you address that?
I could address it just to give people a little bit of context. Like the EU says the motor power has to cut out above 25 kilometers an hour. For sure, you can have a hub motor and run beyond 25 kilometers an hour, but the all-axle motor has a little bit of drag whenever you're riding unpedaled because you have the core losses. So in our motor controllers, we add this virtual freewheeling feature where the controller is powering the motor, but with only enough juice to overcome that drag. So the motor's not helping push the vehicle, but it is still drawing power. So in a strict interpretation of what does this rule mean, you might say, oh, that's forbidden. You can't have even 30 watts going into the motor to overcome the drag. I have no idea whether this would raise problems or not, but I do know that 6E had the exact same problem. So they have a pedal generator bike. And so on a normal bike, you can pedal beyond 25 just fine. You just can't have the motor assisting. But they said, well, there's no way to not have the motor assist in a pedal generator bike. So I presume the law was adapted based on their input to very much clarify that if you have a pedal generator, the motor can still power the bike above 25 kilometers an hour, as long as that power does not exceed the mechanical power of the person spinning the pedals. So by the same token, the power output of if we have electronic power in the motor that just makes the power output of the motor 0 watts instead of negative 40 watts, it should be totally compliant. And I don't imagine anyone challenging us too hard on that point. But European laws are a whole entire.
But it is the EU, Justin.
Yeah,
so not always a straightforward case. All right. From my buddy Mark Feldman. Hey, Mark. How can one purchase this to be fitted to a Catrike 559 direct through a bike shop? So, Justin, you talked in our interview about the fact that you think you were going to start taking orders and such. So, that would be a good thing to bring us up to date on. Where are you with sales availability?
Sure thing. So we do have a sign-up sheet for people who want to put an initial deposit down, which really helps us gauge the interest and the relative ratio of interest in Freegen versus Magic Drive motors, which will also help us, cover all the setup tooling fees to get production up and started. The main question is initially it would be direct because it takes a while to set up dealer networks and have dealers come to understand how to support and install the technology. So we're looking really for technically inclined early adopters at this point who understand the tech, the risks of taking on something new, the fact that the initial release is inevitably going to have wrinkles that need to be ironed out, various updates to firmware as we get more feedback from an increasing number of users. And then hopefully as it matures within, the span of a year or so, then it would be something that some bike stores, especially specialty bike stores, would embrace, becoming resellers and installers for. But right now we're looking for the more hardcore enthusiast who's already been familiar with tinkering with bikes to be the early adopter crowd. It's not yet mature for everybody.
Right. There are plenty of those guys out there for sure. So, all right. And lastly, a very nice comment. I don't know if you need to respond, but Scott Allen Hagen-Miller says, Magic Drive sounds awesome, which, it really does, guys. So, all right, that was all the ones I had there. There's been a few more comments popped in since. Let me just see if there's anything else that is of importance. What is approximately? So, okay. Lost JR. How does it work for climbing? So I'm not sure exactly what he's talking about here, but I guess the Magic Drive, Alon, you talked a little bit about this when we chatted. You want to address maybe a little bit more in detail about climbing with Magic Drive?
Yeah, with Magic Drive with a single motor, because maybe we want to talk about it, but there will be a dual motor setup coming. So with a single motor, your torque is fixed mechanically by the chain ratio. So you are in a fixed gear. You're really in a single speed gear. And that gear should be good enough for you to climb. So it's easy enough to allow you to climb relatively easily. And basically, you can set it up, but it's not adjustable on the ride. It's just, you can set the sprocket ratio as you please. And that's the torque you're going to get. Now, if it's low enough, it's easy to climb. It's basically, on all the bikes we build by now, it's very easy to climb on a hilly city. I guess not long climbs, because then you will get tired and the motor might get hot. But just on a like hilly Vancouver is fine, and it's quite hilly. So yeah, you can climb it, but you do feel it. So it's linearly more effort than on the flat. It's because you're in a fixed gear. It does not add torque. So yeah, on one hand, it feels like a normal bike with a low gear, so it's harder the more the grade is. On the other hand, it is low gear, so it's not that hard. It's working. It's basically working.
Okay. Well, I think that covers the questions there and the ones I had. So with that, any final words before we leave you guys? Anything you wanted to say that we've left out?
I'm just
They're saying, look, it's been 2 hours. What could we possibly have left out?
I guess I'll add. So we have promised a part 2 follow-up video. One of the things we didn't address in any of this so far was clutches and throttle use. And so there's a lot of permutations of this Magic Drive. What we've talked about now is just the simplest and least risky initial implementation and rollout, where we have the disc and the cog on the one side, and nothing fancy going on with internal clutches. But there are options to have the a system that can be worked entirely with throttles without the pedals spinning or taking a load on the torque, and to even reverse via throttle without having to backwards pedal. And there's also options to have a mechanical linkage so that even if all the electronics fails, you can still pedal the bike in just like a 1-to-1 ratio, just like you would if the cog was directly on the side plate of the wheel. If it's a topic that's of interest, it'll probably be about 3 weeks from now that we'll be able to do a in-depth follow-up video that goes deep in the weeds. And also deep in the weeds, Alon alluded to the challenges of controlling the motor control and these peaks of current and everything. So we'll share a lot of graphs and info and data on what it took to get it to this state and what is still remaining to be done to hit that end of year release point.
Very nice. Alon, you good?
Yeah, fine.
Okay, let me just leave it there then. Let's emphasize, because I'm not sure we really did in the interview, that Grin Technologies has a wonderful YouTube channel as well. We kind of alluded to some of these videos that Justin has done. They're awesome. They're in-depth. They're fun to watch. So please, if you're at all interested in any of this, go to the Grin Technologies YouTube channel as well. And he'll be keeping you up to date there, I guess. So with that, I'm going to thank Alon and Justin for all the kind work they've done with me and all the time they've spent to put this together. Fellas, I really, really appreciate it. And we hope to be talking to you again soon.
Thank you, Gary. Thank you.
Much appreciated. May see you at CycleCon in September.
You keep saying that. I'm going to be looking for you.
Hold me to it.
All right. We're going to talk about that
There could be
later.
some rideable updates at that period. So
okay,
all the best.
good.
Thanks, everyone, for tuning in. And
okay. Thanks, guys. All right. Well, let's move along to viewer submissions. We don't have any today, but just to let you guys know, if you've got pictures of your accomplishments, rides, events, anything like that you want to share on the Laid Back Bike Report, just contact us at laidbackbikereport@gmail.com. And we will be happy to work with you on bringing that to our viewers and sharing it with them as well. Now, if you like what you saw today, I hope you all did, and what you see every month, it's only possible because of the amazing sponsors of the Laid Back Bike Report. Let me tell you who they are right now.
TerraCycle. Ride in comfort, style, and laid-back bliss. At TerraCycle, we've been laid back since 1996. See more at t-cycle.com. And TerraTrike Green Speed, the best in leisure, performance, adventure touring, electric, and portability. Wherever your adventure leads, TerraTrike will take you there. And Green Speed, where Ian Sims designs bring performance through science and engineering. And Laid Back Cycles, your go-to store for Catrike, Ice, TerraTrike, and now AZUB Recumbent trikes. They ship nationwide and offer financing to get you rolling. Plus, check out Laid Back Mickey on YouTube for all the latest tips and reviews on recumbent trikes. And Bicycle Man, where you can find new and used recumbent trikes and bikes. We're located in Alfred Station, New York, and have over 100 bents in stock and ready to try. So why wait? Come ride, then decide. And AZUB. The team at AZUB is proud to offer the latest 5th generation Bosch Performance CX motor. The CX offers 250 watts of nominal power, up to 750 watts of maximum power, and 100 Newton meters of torque. The optional dual battery system has an impressive range of up to 200 miles. This system can also link the electronic shifting of the roll-off gearbox, something that no other motor but Bosch allows. To learn more about all this, visit azub.eu and feel free to configure your dream bike. And Stein Trikes. Fully suspended and with 4 inches of travel over each wheel, our colorful trikes will have you gliding over rocks and curbs with ease. Wild one, I think I love you. Check out stein-trikes-us.com to learn more. And Recumbent PDX, Catrike's West Coast Megastore. Schedule your test ride on trikes with pedal assist electric from both Bosch and Bafang, roll-off and Schlumpf component groups, and adaptive builds. Experience the joy of Catrike. And Utah Trikes, working hard to get more people on trikes and encouraging you to relax, spin fast, and ride trikes. Utah Trikes also has a great YouTube channel chock full of useful advice. Subscribe today. And Catrike, where passion meets engineering. Lightweight, efficient recumbent trikes proudly made in the USA. Take a test ride today. You can find a dealer near you at catrike.com. And Baketta Bikes, the leading innovators in two-wheeled recumbent design. Baketta is the only brand of recumbents featuring a full line of electric assist bikes, performance bikes for your favorite club ride, and recreational bikes for spending the perfect day out cycling with friends. Head over to BakettaBikes.com to learn more. And Angletech, your premier destination shop. The experienced crew here can take you step by step and custom tailor a cycling experience that is just right for you. Discover where comfort hits the road at their shop in Colorado Springs or visit their website at cycledifferent.com. And HP Velotechnic, innovative designs that blend ergonomics, cutting-edge suspension, and thoughtful modular accessories to take your riding experience to the next level. Enjoy a smoother, faster, and more relaxed way to ride. Visit us at hpvelotechnic.com. And Grin Technologies. Grin has championed the electric bike movement for over 20 years, specializing in unique parts for do-it-yourself e-bike upgrades. Their lightweight yet powerful hub motors with regenerative braking are engineered to perfection and can fit on virtually any bike, trike, or quad platform. Check them out at ebikes.ca.
All right, guys, announcements. Well, there's a few videos that we have uploaded over the last few weeks that have come from our forays into Europe. You might have seen the more recent one with David Massot from Passion Velomobile in France when Trey and I were there, and Daniela Gonano as well, where we interviewed him at his home just outside of Paris. And he talks about his Velomobile with solar panels, which he calls the best touring bike in the world. So you might want to catch those on our Laid Back Bike Report YouTube channel. And actually, we just returned from Europe again. I had a couple weeks there, and we did a few more interviews, which I'll be editing and popping up on the channel here in the next few weeks. So keep your eyes posted for that. Hope you guys will enjoy those. Now, next Laid Back Bike Report will be August 16th at 2 p.m. Eastern Time, as usual. And we'll let you know what that's going to be about as we get closer. Now, how can you support the Laid Back Bike Report? Well, you can like us on Facebook. You can subscribe to us here on YouTube. And Trey's going to pop up a little QR code right up there in the corner. And you can scan that with your phone. It'll take you to Laid Back Bike Report website, where you can find out much more about us, past shows, things coming up, of course. You can buy a hat. You can become a Patreon sponsor like all these fine folks have there. We always appreciate that sort of support as well. So any way you can do it, even if it's just watching us every month, we thank you. All right, let me thank the crew. Let's bring all the crew up here. Oh, it's just Trey. Trey, of course. Trey, thanks. Great job today, pal. Filling in for Larry, who is off on assignment or something. I'm not sure what Larry's doing this month, but We are appreciative of what you've done for us today, Trey. And I know you're kind of keeping an eye on the World Cup as well. Good job doing two things at once. I have a hard time doing that myself. So thank you to Trey, our crew, either here today or not. And most of all, thanks to all of you out there for watching every month. A Laid Back Bike Report. We appreciate that. So until our next webcast, from all of us here at the Laid Back Bike Report, so long, bent riders.